Hello everyone. Today in this session we are going to discuss about Go back and ARQ. Go back and ARQ. To improve the efficiency of the transmission, multiple frames must be in the transition while waiting for the acknowledgement. In other words, we need to let more than one frame to be outstanding to keep the channel busy while the sender is waiting for the acknowledgement. So what happened in during the transmission, in order to improve the efficiency of the transmission, all the multiple frames must be in the transition while waiting for the acknowledgement. So when the frames are more than one, that is to be outstanding to keep the channel busy while the sender is waiting for the acknowledgement. The first is called go back and automatic repeat request. In this protocol, we can send several frames before receiving acknowledgement. We keep a copy of these frames until the acknowledgements arrive. Sequence numbers. Frames from a sending station are numbered sequentially. However, because we need to include the sequence number of each frame in the header, we need to set a limit. If if the header of the frame allows m bits for the sequence numbers ranges from 0 to 2 to the power m minus 1. For example, if m is 4, the only sequence numbers are 0 through 15 inclusive. However, we can repeat the sequence. So the sequence numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 like that. That will be repeated. In other words, the sequence numbers are modulo 2 to the power m. In the go back n protocol, the sequence numbers are modulo 2 to the power m, where m is the size of the sequence number fields in bits. Sliding window. In go back and automatic repeat request, the sliding window is an abstract concept that defines the range of sequence numbers, that is the concern of the sender and the receiver. In the other words, the sender and receiver need to deal with only part of possible sequence numbers. The range which is the concern of the sender is called the send sliding window. The range that is concern of the receiver is called the receive sliding window. The window at any time divides the possible sequence numbers into four regions. The first region from the far left to the left wall of the window defines the sequence number belonging to frames that are already acknowledged. The second region defines the range of the sequence number belonging to the frames that are sent and have an unknown status. The sender needs to wait to find out if these frames have been received or were lost. The third range defines the range of sequence numbers for frames that can be sent. However, the corresponding data packets have not yet been received from the network layer. Finally, the fourth region defines sequence numbers that cannot be used until the window slides. So here the window at any time divides into possible four sequences, four regions. One region, first region, that is from the far left to the left wall of the window, that defines the sequence number belonging to the frames that are already acknowledged. Second region will defines the range of the sequence number belonging to the frames that are sent have unknown status. It is in the unknown status. The third range defines the range of the sequence numbers for the frames that can be sent. However, the corresponding data packets have not been received by the network layer from the network layer. The fourth region, that is final region, defines sequence numbers that cannot be used until the window slides. This is the send view for the go back in our ARQ. In this frames already acknowledged, that is the first region. Second region, frames sent but not acknowledged, it is in the outstanding. And the third region is frames that can be sent but not received from the upper layer. And the fourth region is frames that cannot be sent. That is, the first one is the send window before sliding. After sliding, it will be like this. It will be after sliding, after sending the sliding, so it will be the window will be like this. The window itself is an abstraction. Three variable defines its size and location at any time. We call these variables SF send window, the first outstanding frame, SN send window, the next frame to be sent, and S size send window size. The variable SF defines the sequence number of the first oldest outstanding frame. The variable Sn holds the number sequence that will be assigned to next frame to be sent. Finally, the variable S size defines the size of the window which is fixed in our protocol. So this is the what is that variables, three variables that will be defined in this. So that is, one is SF, Sn and S size. SF is the send window in the outstanding frame. Sn is the send window in the next frame to be sent. S size is the send window size. This is receive window for the go back NRQ, go back in ARQ. In this receive window before sliding, receive window will be like this. Frames already, it has two regions, frame already received and acknowledged, and the frames that cannot be received until the window slides. And the second one is window after sliding. The window will be slided after sliding the window will be like this at the receiver end. Example, that figure example of the go back n. This is an example of a case where the forward channel is reliable but the reverse is not. No data frames are lost, but some acknowledgements are delayed and one is lost. The examples also show how cumulative acknowledgements can help if acknowledgements are delayed or lost. This is the diagrammatic view of the go back n. In this we have initially the data will be sent and thus timer will be set, and the sender A will send the frames to the receiver B. Initially the frame 0 will be sent and will get the receiver will get the acknowledgement 1 and will send the acknowledgement 1, and again after receiving the acknowledgement, frame 1 will be sent and acknowledgement 2 will be receiving. By that time frame 2 sent, there will be a loss of the data for the acknowledgement 2, and for the frame 3 acknowledgement 4 will come in the given time. In this diagram it shows what happens when a frame is lost. Frame 0, 1, 2, 3 are sent. However, the frame 1 is lost. The receiver receives the frame 2 and 3, but they are discarded because they are received out of order. Frame 1 is expected, but that receives frame 2 and frame 3 order. The sender receives no acknowledgement about the frames 1, 2 and 3. Its timer finally expires. The sender sends all outstanding frames 1, 2, 3 because it does not know what is wrong. Note that the resending the frames 1, 2 and 3 is the response to one signal event. When the sender is responding, to this event, it cannot accept the triggering of the other events. This means that when acknowledgement 2 arrives, the sender is still busy with the sending frame 3. The physical layer must wait until this event is completed and the data link layer goes back to its sleeping state. We have shown a vertical line to indicate the delay. It is the same story with acknowledgement 3, but when acknowledgement 3 arrives, the sender is responsible for acknowledgement 2. It happens again and again when the acknowledgement 4 arrives. Note that before the second timer expires, all outstanding frames has been sent and the timer is to be stopped. This is about this session. Thank you.